Keynote session number 2 for the day. Building autonomous DevOps with AI and telemetry intelligence. This will be conducted by Mr. Deepak Gupta, VP of Engineering, CARS 24. Let me give a small brief about sir. Mr. Deepak Gupta is a senior executive and the vice president of engineering at CARS 24 Financial Services, boasting over 2 decades of extensive experience at the nexus of technology and business. He is a distinguished figure in fintech and AI domains, recognized for his thought leadership and extensive innovations in artificial intelligence, machine learning, and data science. He is an industry expert in modern engineering, enterprise architecture, microservices, and cloud-based scalable platform solutions. Mr. Deepak has been pivotal in developing resilient engineering platforms, scalable fintech solutions, and cutting-edge websites, apps, and products. With this, may we invite Mr. Deepak Gupta on the dais with a huge round of applause, everyone.
Good morning. Good morning. I think it's morning, it's not lunch. All of us should be having some energy if we have not spent our night monitoring our systems and recovering them from some failover. So thank you, and honor to be here in front of all of you. And so I'm Deepak, as I've got the introduction. So I've been into the industry, so I think growing old with the industry, and have seen the era from where we try to grab the logs and try to figure out what's happening, to the era where we have APMs, which are very beautifully showing all the graphs and that. But yes, today what we're going to do is we're going to talk about something where how we see the next version of the observability, which is DevOps 2.0, Observability 2.0, and how the mindset is changing, how the shift is happening, where we already know, we have learned a lot about our systems, how do we manage them, how do we understand them, but how do we make a shift to see that we build the system which are autonomous in nature, which are self-healer, self-recoverable in nature, and need a least of the monotonous jobs, right? So let's begin, and I'm going to share my vision and my perspective around it. So let's see. Before that, let's do an anthem, because anything we do good, we should start with an anthem. Let's play that.
दोस्तों में बैठा मैं गेमिंग कर रहा, अगले लॉन्ग वीकेंड की प्लानिंग कर रहा। कॉल मुझको आई, मैं झट से डर गया, बैठे बैठे लग गई, मुझे पता भी ना चला। नल चक्की लगाया, अरे नल चक्की लगाया, यूनिट टेस्टिंग भी किया। दोस्तों संभालो, मेरा कोड फट गया, पहली ही रिलीज में एक्सेप्शन आ गया।
Thank you, and I think it's the anthem of every developer, and we have seen this scenario happening in all of our lives, I believe, where it's the middle of the night, or we are in a function, or we are planning something, and we have to worry about that our code has been broken. Now moving on to what is the complexity, why it's being so complex even, right? It has to be a very simplified thing, right? You deploy the code, you monitor the application, you see how it's happening, and the life should have been so easy. But it could have been, but if we have not moved along on how our applications has become so complicated, so distributed, microservices, IoTs, different nature of logs coming up at a different speed, different variations. There are so many applications playing a role in the overall system health, right? That has a lot of problem of the scale, and definitely the scale at which we are growing, everything is growing, right? And in order to catch up with this, the traditional monitoring is failing, right? Because whatever we're trying to do in the traditional, whatever the beautiful graph, whatever the APMs we try to do, everything is very reactive in nature, right? So we hope something will happen, and then we react, and we react very quickly, and we try to recover the system, we try to get back on the system in a very efficient manner and very fast manner. But end of the day, it is being reactive, right? And to make it more complex, as I said, the data is growing and growing and growing. So we all struggle with the fact that the most essential aspect in overall this monitoring thing, observability thing, is the data, which is growing at a rapid rate, because our scale is growing, our applications are growing, our features are growing, our customers are growing, everything is growing, and we have a lot of data overload. So if we try to analyze that data, it becomes very complex and very problematic in nature. So if there is a problem, there has to be a solution, right? Because if there is no solution, then the problem does not exist in nature. But that solution has been, and is it into the place from long, right? So we have seen this problem being growing over the decade, and we have tried to answer it in various different format by creating very good APMs, very different graphs, as we said, putting up the alerts, putting up a lot of alerts into the system, checks into the system to give us the alert where something goes wrong. But this Observability 2.0 needs a paradigm shift from all this thought process and make a shift where our systems are built in a manner that we can ask things which are not into the point of time or which are in a very human nature. The core principle is to have leverage the data. Like we have so much of the data. Why we can't leverage the data and put a brain, which is the generative AI or the AI brain on top of it, to analyze it in a much better details. Then and what is the objective? And the overall objective of this paradigm shift and bringing the Observability 2.0 is to become proactive than the reactive in nature. So reactive, we just saw that we react to the situation, and the proactiveness is we are prepared. What are the three pillars in order to do this, and in order to achieve that? Is preventively we detect the issues, we do the automated root cause analysis, and we do the context-aware pipelines. Not just the pipelines which shift the data and put the data and dump the data somewhere, there has to be context-aware. Now, if we look at the first pillar, which is the predictive analytics. So if I ask you, what comes to your mind, or what is the base of any predictive thing that we do in predictive analytics that we do? What is the basics and the most important aspect to it? Historical data. And what is the most abundance in the terms of monitoring and observability that we have? Like one thing which can assure that it is growing and we have a lot of it is the data. So it doesn't seem to be very difficult and very non-intuitive that we do not put a predictive analytics on the telemetry data, right? Any subtle deviations that we see, that either we can miss it out as in a form of the graph or the human, it can be captured or can be caught by our AI ML models or the generative models, right? Then the proactive alert. So what happens when the alerts comes into the picture? We get typically the alerts which you have to translate into something which is meaningful. For example, you say the CPU will go to the 95%. So what? 95% is just a number. How different it is from 75%. Someone has to put the human brain to say, okay, 95% is that system may go down. So why cannot we get the insights, or we can get our alerts in a manner which tells us, right, that which is more human nature, that, okay, if you do not act, the system will go down in the 15%. Doesn't matter whether it's a CPU or something. Or taking it to the next level, why even I need an alert to tell me why I cannot get the remediation straight away, right? It says, okay, your system will go down in 15 minutes, 15%, I have to shut down some service, or I have to grow something, I need to increase connection pool, or I need to increase CPUs, I need to increase. So there the automated remediation comes into the picture based on the perspective of how I am able to predict what's going to happen based on the historical data, but at the same time using it for the forward-lookingness, not the backward-lookingness. Now then the AI for the real-time anomaly detection in the RCAs. We all hate doing the RCAs, right? There's a battle which goes on between the couple of people saying, no, it's not my fault, it's someone else's fault, it's someone else's fault. But what if it has happened automatically? We provide enough data to our system, not just about the logs of the application. We provide the stories which are happening, which provide the code. We provide the code reviews. We provide every aspect of the data as a part of our as a context pipeline, which we'll see in the thing. And the system is able to do the RC of its own to tell what is the problem, what is the root causes, whether the code review was not done, whether it's a coding issue, whether it's a functional issue, whether it's a requirement issue. Now, and the third pillar, which is the context-aware pipeline, as I said, There we do the data enrichment. Do not just pass on the data, we enrich the data with a lot of information, which various different sources, not just the log, whether it's our stories, whether it's our the release notes and other functional documentation, and it can create a story and can collaborate issues and put a Gen AI on top of it in order for us to raise a question in a human language and able to grab the answer which human can understand, rather than putting a lot of effort in understanding tools and putting up the people who understand the tools, not the language. Now, at the same time, the environment optimization, that we put a lot of context around the environment as well in order to build these pipelines and to see how. Okay, so in all this journey over the last decade, the major focus on how best dashboards we can create, right? How better the insight, the visualization the dashboard can give. But end of the day, every dashboard needs to be understood by someone and grab the insights out of it, right? My memory is peaking, why the memory is peaking. My CPU is going up, why the CPU is going up. There is a particular time in the day when it is happening. It is a particular situation when it is happening, or some campaign was run. So all this needs to be taken into the context and drive the insights out of those dashboards. So why do we need even dashboards? Can we not grab or directly create the insights out of it, which gives the insights about our application, about situation, about the problem, and we leverage that insight and interpret it using the AI and create something which is more meaningful, and we move toward the aspect of insights to the actionables directly. Okay, and that is where when we have got the insight, we know that what is happening. And if we are able to understand and learn what action usually needs to be taken based on those insights, we can create an autonomous self-healing environment where the system is able to take decisions and act and create the system which is foolproof from not going down or can recover of its own. So this is where the revolution of the GNI autonomous production environment, where we see the proactive scaling, we see the automated optimizations, and we have the self-securing systems. And that's how I will like to conclude on this aspect, that we have to accept that the complexity would be there, complexity would be growing, and it is the new normal. We have to build Power Observability 2.0 on that complexity and making it easier, and use the AI and the Gen AI as a catalyst to achieve that. On this note, thank you everyone. This is Deepak, and thanks for listening in.
Thank you so much. And may I invite Mr. Saurabh Kothari, Senior Enterprise Solutions Engineering, Datadog. Sir, please join in to present a small token of appreciation to Mr. Deepak.